Welcome to an introduction to probability. Probability is one of the final topics we look at in data management, and it builds on almost everything we've done so far in the course. So it covers everything from percents to other kind of conversions we have in data, but then we use the counting techniques like permutations and combinations, so factorial, NPR, NCR, tree diagrams, all of it gets tied into that. What I like about probability is that unlike some of the other units, there's really no new formulas to learn here. All that probability is a chance of an event occurring. We show that final answer usually as a fraction of a percent, but we can also show it using odds or a ratio. But if you look at the probability formula, it very simply is what you want over all possibilities. So in terms of a Venn diagram, and we'll use those a lot in probability too, you're looking at the circle of the Venn diagram that you want, and then dividing that by the sample size, so the entire Venn diagram. So if you're dealing with percents, it's easy. The sample size will be over 100, and that's why we use percents so much with probability. So regardless of the question I ask you, you're always going to start with, what is it that I want? What is the event or the part of the Venn diagram I want? And then you're going to divide that by the sample size. And then from there, you will have your probability. So simple examples, everything from you have a pencil case, what's the probability of pulling out a red pen based on what else is there? But we'll do a lot of questions with dice, with cards, spinners, because they're a very predictable kind of probability and one that can easily be calculated. So what is the probability of rolling a 4 on a single die? Go back to your formula. It's what you want over all possibilities. You want a 4, there is exactly one 4. So you would go and put 1. There are 6 possibilities when rolling a die. It is correct to leave it as a fraction of 1 over 6 or as a percent of 16.7%. And for the most part, we'll always round to 1 decimal when dealing with percents. So what's the probability of rolling a sum of 4 with 2 dice? Same formula. It's what you want over all possibilities, but sometimes you got to do a little bit of work to get those 2 numbers. When it comes to questions with dice, there's really no shortcut. You can use a little chart. There's some excellent charts online. You want to make yourself a little note to do a search for 2 dice possibility charts. You'll get a nice little grid that shows all 36 possibilities. But you can also just use some common sense. So what you want is a 4. There are 3 ways to get a 4. If you roll a 1 and a 3 on the 2 different die, if you roll a 2 and a 2, or a 3 and a 1. Sample size, it's going to be 36. There's 2 dice, 6 possibilities for the first times 6 possibilities for the second, and you have your 36. So final answer here, probability for a sum of 4 is 3 over 36. What I want is a 4. There's 3 ways to do that. There's 36 total possibilities. You cannot leave the answer as 3 over 36. Fractions always have to be reduced. So correct answer would be 1 over 12 or 8.1%, or putting both. And that is really all there is to probability. Every single question I give you in the next 2 weeks, you will simply use the formula, what you want, divided by all possibilities. And the only thing that makes this unit tricky is that sometimes there's a fair bit of math to do to figure out what you want. Maybe it's going to involve NCR and looking at different combinations that you have to do, maybe some multiplication of different possibilities, or an OR situation where you're going to have to do 2 different things and then add them in order to figure out what it is that you want for probabilities. Backing up though, a bit of terminology. There's not a lot of definitions you need to learn in this unit, but here are 3 of them that you're required to know and that will be on the quizzes. There are 3 main types of probability. One is subjective. There's a video that I'll put up, a great little video that Rick Mercer did that just looks at the subjective probability and numbers behind weather forecasting, especially those long-range weather predictions. Subjective is really, at best, an educated estimate. There is no specific calculations. Whether it's an example of the Leafs trying to make the playoffs, There's a meme that went around that looked at this weird little phrase that 80% of all stats are made up on the spot, including this stat, because of course there's no good way to calculate how many stats get made up, whether it's by people on the news or by data management teachers. So subjective is really when we're using probability and percent chance to try to prove something that is either difficult to prove or where we're just trying to manipulate the situation. Experimental probability is done all the time. And anytime you play a game, you're actually doing an experimental probability. So if you're playing a game like Monopoly or anything with dice, any kind of game that has a spinner or anything like that, every time you roll the dice, every time you take a card out of the deck, you are doing experimental probability. And it's based on a set number of trials. So if you pull a coin out right now and flip it 10 times, we know that you should get tails 50% of the time and heads 50% of the time, but it's not actually going to always happen that way. And that's why probability works. It's why gaming works. It's why people lose so much money at casinos, because there's a chance of a big win. And yet we know that with experimental probability, that your chances are lower of the more extreme things happening. So if you flipped a coin 10 times and got tails 3 times and had 7 times, that's your 30% chance. That's what the experimental probability is, but it's unlikely. What's more likely is that you would get 5 and 5, 6 and 4, 4 and 6, or something like that. That's a bit more common. So for experimental probability, you actually have to be doing an experiment. Pull 52 different cards out of a deck and look at the probability of them happening. Spin a spinner multiple times, sit there and flip a coin 100 times and see what happens. So the third and most important part that you'll mainly use in the probability unit is theoretical probability. It is the most common. It's what we actually just did at the beginning of this handout. It's the probability of what should happen, and it is based on a formula. That formula is the probability of event A is the number of ways A can happen divided by the number of the total sample size. And if that Venn diagram language confuses you, then just go with the simple formula that probability of an event is what you want over all possibilities. And that's the formula. So if you flip a coin, you have a 50% chance of getting a tail. Probability of a tail is 1/2 or 50%. So now when we go back and look at these coin flip questions, yes, you can get a 30% chance of tails as an experimental probability, but if you were to flip that coin way more than 10 times, if you were to flip it 100 times, 1,000 times, or 1,000,000 times, what's the chance of you actually keeping it at 30%? And the chance is almost nothing. If you flip a coin 1,000,000 times, it is going to be very close to half of the times you get a tail and half of the time you get heads. And that leads into our final part here, where we look at some of these different terms and how those 3 types of probability relate. So as the number of trials in your experiment increases, what's that? Trial is the number of times you actually flip the coin, spin the spinner, draw a card from the deck. As the number of trials in your experiment increases, the experimental probability becomes closer to the theoretical probability. So what might start as a 30% chance of flipping tails will become a 50% chance, which is the theoretical probability. So when we talk about this term, the complement of A, what we're really talking about is the opposite of the event happening. And that becomes very important in the next topic with odds, but in general, it's important to understand the probability of something happening versus it not happening. So the complement of A is just the probability that event A will not happen, and that gives us the simplest formula of the entire course, which is the probability of an event happening plus its complement. The probability of it not happening will always equal 1 if it's fractions, or 100% as a percent. And so if we look at the complement of not rolling a 4, we are just looking at 5/6, 83.3%. Those 2 events combined together give us a probability of 100%. And I hope you can visualize how this could be shown in a Venn diagram. It would be very simple. There would be a small circle called A, which is rolling a 4. There's one way of that happening. And then there would be a 5 outside of that circle that goes and shows how not to roll a 4. And then our sample size for probability will always be 100%. So anytime you are drawing a Venn diagram for a probability question, draw that box, put S is equal to 100%, pick up a mark for having that kind of format done, and then go and put circles in to represent the probabilities. So that's it. That is an introduction to probability. You'll have many different types of questions in your homework and some practice quizzes, but every single question uses the same method of what you want divided by all possibilities, and then represent it as a fraction or as a percent.